In this video, we're going to be finding the volume of pyramids, cones, cylinders, spheres, and hemispheres. We've already learned how to find the volume of prisms, and these are just going to be based off of that. So our I can statements are, I can find the volume of three-dimensional shapes, including prisms, cones, pyramids, and cylinders. And I can use the volume formulas to find the volume of a three-dimensional shape. Volume of a pyramid is what we're going to start with, and the volume of a pyramid is equivalent to 1/3 the volume of a prism, as long as they have the same base area and height. What that says is if we had 3 pyramids that had the same base as a prism, it would take 3 of those pyramids to fill up a prism. The formula to find the volume of a pyramid is volume is equal to 1/3 multiplied by the area of the base multiplied by the perpendicular height. The perpendicular height is going to be the height that is inside the pyramid. So make sure you're using the height that's on the inside as opposed to the lateral height, which we discussed on Friday. So let's do a few examples. This first example, we have a pyramid. So I'm going to use the volume formula. Volume is equal to 1/3. Now we need to find the area of the base. In this case, if we look, I'm going to shade in this base, and this base is a rectangle. Recall the area formula of a rectangle is area is equal to base times height. The base and height of this rectangle on the base is 6 times 11. So this here represents the area of the base. Now we multiply that by the perpendicular height. So that's the height inside that makes the 90-degree angle, which in this case is 12. And again, 12 represents the perpendicular height. So I want to show you how to type that in a calculator, because typing in 1/3 can be a little tricky. So when I type in 1/3, I put it in parentheses and I do 1 divided by 3. Then in the next set of parentheses, I would do 6 times 11 for the area of the base, and then multiplied by 12, which is the perpendicular height. I hit enter, and I got 264. So the volume of this first pyramid is 264. Now, since we're talking about volume, remember volume, we always label it with units cubed. So it would be 264 centimeters cubed for the volume of that first pyramid. Okay, let's take a look at the next one. We have another pyramid, so I will be using the same formula. 1/3 times the area of the base times the perpendicular height. In this example, the base is a triangle. So this base is a triangle, and the area formula for a triangle is 1/2 base times height. Remember, to find the base and height in a triangle, you have to find the two sides that are perpendicular, that touch the right angle. I am showing you that right now in red. This right angle touches these two sides, and those sides are 8 and 6. You'll notice 10 does not touch the right angle at all, so that should not be used as part of the area of that triangle. So for the area of the base, I would do 1/2 times 8 times 6. Again, that's the area of the base, which was a triangle. We multiply that by the perpendicular height, which is inside the pyramid, which in this case, again, happens to be 12. That was the perpendicular height. So again, let me show you how to type that in the calculator. So I'm going to type in 1/3 in parentheses, multiplied by 1/2. I use 0.5 for 1/2, times 8 times 6, that was the area of the triangle, multiplied by the perpendicular height, which was 12. I hit enter, and I end up with 96. So the volume of this pyramid is 96, and since it's volume, we're going to label it with units cubed. So inches cubed would be that final answer. One last pyramid that I want to look at. Again, it's a pyramid, so I use the same volume formula, 1/3 times the area of the base times the perpendicular height. In this case, this base figure is a figure we talked about on Friday. It is a regular polygon. We discussed that a regular polygon area formula was 1/2 SAN. S was side length, A was apothem, N was number of sides. So when I'm trying to find the area of the base, I would do 1/2, it's part of the regular polygon area formula, times the side length. Well, the side length in this picture here, it shows me that I do it in red there, is 6, so 1/2 times 6. The apothem, which is the perpendicular distance from the center to the edge, they tell me that is 5.2. N means number of sides, and it has 1, 2, 3, 4, 5, 6 sides. So that right there represents the area of the base. This is just a coincidence that the perpendicular height in this case is also 12. It is not always 12. This is just purely coincidental here. And that is the perpendicular height. So let's type this one in the calculator as well and show us how to do that. So I'll type in again 1/3 in parentheses, 1 divided by 3. Now the area of the base, 0.5 or half, times 6 times 5.2 times 6, multiplied by the perpendicular height, which was 12. When I hit enter, I got 374.4. So the volume of this figure is 374.4 kilometers cubed, again, because we're talking about volume. So for the volume of pyramids, it's 1/3 times the area of the base times the perpendicular height. Identify the base figure, find the area of it, identify the perpendicular height, and plug those in. The next shapes I want to talk about are cones and cylinders. Okay? So the volume of a cylinder formula is volume is equal to pi r squared h. The area of the base, okay, that's pi r squared, that's the area of a circle. And h is height, which is the distance between the bases, just like we did for other prisms. Remember, r means radius, which we discussed Friday is the distance between the center to the edge of a circle. And h in this case means height of that cylinder. Now, similar to the prism-pyramid relationship, the volume of a cone and cylinder have a similar relationship. The volume of a cone is 1/3 the volume of a cylinder if they have the same base area in height. So same thing, if they have the same base and height, it would take 3 cones to fill one of those cylinders. So volume of a cone formula, it's going to be the same as a cylinder, except it will have a 1/3 in front of it. So for the volume of a cone, it will be 1/3 pi r squared h. R is still radius, h is still height. So let's do a couple of these. So if we look at the first one, this is a cone. So it's going to be 1/3 pi r squared h. So r is radius, which is the distance from the center to the edge. Well, in this first example, they gave me the whole distance from edge to edge through the center, which is the diameter. If I want the radius, we discussed that we have to take the diameter and cut it in half. So my radius here would be 8. So 1/3 pi times 8 squared, and the height of this cone is 16. Remember, volume, we want the inside height, the perpendicular height. So if we're typing that one in the calculator, I would do 1/3 times pi. The radius was 8, don't forget to square it, times 16, and hit enter. Remember, when you use pi, you will get a decimal that goes on forever. So for the purposes of these problems, I'd like to round to the hundredths place, which is 2 decimal places. So this would be 1072.33, because 0 would keep that 3 the same. So the volume of this cone is approximately equal to 1072.33 meters cubed. Volume is units cubed. The next example is of a cylinder. So I'm going to do the same thing, but without the 1/3. Cylinder formula is pi r squared h. So for the volume of this, it's pi. The radius, they gave me the radius this time, it's 6. It's from the center to the edge of the circle. So it'd be times 6 squared. And the height in the cylinder is 5. So I'm going to multiply by 5. So let's practice typing this in the calculator. So I'm going to do pi times 6 squared, because that was the radius, times the height, which was 5. If we're rounding to the hundredths place, 6 would bump that 8 up to a 9. So we'd have 565.49. So the volume of that cylinder is about equal to 565.49 centimeters cubed. We have one more cone. So we're going back to the cone formula. We have to put that 1/3 because it takes 3 cones to fill up a cylinder that have the same base area and height. So 1/3 pi, we need a radius. Well, here they gave me the distance from the center to the edge again, which is our radius, which is 11. So pi times 11 squared. And the height for this one is 22. So if we practice, again, it's recommended you're practicing typing these in. So I'd have 1/3 in parentheses times pi times 11 squared times 22. That's how it should look in your calculator. When I hit enter, I got about 2,787.6, and it would be 4, because 9 would bump that 3 up to a 4. So volume is about equal to 2,787.64 yards cubed. So that's how you find the volume of cones and cylinders. Remember, cylinders will not have the 1/3, cones do. I will give you both of these volume formulas on your test at the end of the week, but you have to know what to plug in where and how to type it in the calculator. The last two shapes that we need to talk about, last two figures, are volume of a sphere and volume of a hemisphere. So the volume of a sphere is 4/3 pi r cubed. So if we look here, we have two different shapes. Or I'm sorry, we have two different spheres, two examples of a sphere. So we're going to take this and use this formula and apply it to this first example. So 4/3 pi. Now here again, they gave me the diameter. They didn't give me the radius. So to get the radius, I need to take my diameter and cut it in half. 6 divided by 2 is 3. So if I'm going through this now, I would plug in 3 for r. And keep in mind it is cubed now, not squared. So we're going to show you how to type that in the calculator accurately. We want to type in cubed and not squared. So if we're typing this next one in, I would do 4 divided by 3 in parentheses times pi times 3. Now to get cubed, you're going to hit the arrow button that's right above the division sign, right there. Okay, this arrow. And then it'll give you a little arrow, and you want to put 3 to show that it's to the 3rd power. I hit enter, and I get 113 point, it's going to be 0.10, because if I'm rounding to the hundredths, the 7 would bump the 9 up to a 10, which would bump the 0 up to a 1. So this volume is about equal to 113.10 yards cubed. Remember, volume is always cubed. Now, if we wanted to talk about a hemisphere, it's going to be volume is equal to 2/3 pi r cubed. 2/3 because 2/3 is half of 4/3, and a hemisphere is half of a sphere. So if I'm going to plug this in, I have 2/3 pi. We need r again. Again, they give me the diameter, which is 20. So if I want the radius, I have to take 20 and cut it in half to get 10. So 2/3 pi times 10 cubed. So if we type that in, 2/3 times pi times 10 in parentheses, and then don't forget to put it to the 3rd power and hit enter. We're getting about 2094 points, and it'll be 40, because again 5 bumps 9 up to 0, which would bump 3 up to 4. So volume is about equal to 2094.40 yards cubed. The last example, we have another sphere. So I'm going to go back to using the volume of a sphere formula, 4/3 pi r cubed. In this one, they did give me r right away, so I don't have to cut it in half this time because they gave me the radius to start. So it'd be 4/3 pi times 2 cubed. So if we type that in, I'd have 4/3 pi times 2 to the 3rd power. And I'm getting about 33.51. So volume is about 33.51 centimeters cubed. So in this video, we reviewed new formulas and new figures to find the volume of. We talked about pyramids, 1/3 times the area of the base times the perpendicular height, which is inside the pyramid. Then we talked about volume of cones and cylinders, and then spheres and hemispheres. Use these notes to complete your practice assignment.